Hi, welcome back to AP Physics C Mechanics. So we're continuing our journey through Unit 1, which is kinematics. So in this video, in the last video, we focused just kind of talking about some of those descriptors that are associated with kinematics. In this video, we're going to start bringing in the calculus to it, right? So we're going to talk about the difference, what is really the difference towards one of the last things we talked about in the last video, which is average velocity and speed, to now this concept of instantaneous velocity and speed. So the quantity that tells us really how fast an object is moving anywhere along its path is what we call instantaneous velocity, okay? And so the way to think about it, you see the word instant in the word, okay? So it's the velocity at a particular moment in time. So the way to think of it mathematically is that we take the limit of the average velocity as the elapsed time approaches zero. So if you watch one of the calculus videos, so like let's say I want to find what is the instantaneous velocity at 15, right? So what I do is I may start with a rough estimate by doing a secant line, right, which hits the graph at 2 points, okay, which will give me an estimate, right? It's approximately what our instantaneous velocity would be, okay? But what I do then is I can take another set of lines and shrink my delta x, right? So this is my delta x for the first one. Here's my delta x for the second one. So the delta x1 is going to be greater than delta x2 to the point where I turn that secant line into a tangent line at the point that we want, right? And so this is the derivative. So we say that the instantaneous velocity at a particular moment in time is simply the derivative of position at that time, right? So you may be given like t equals 2 seconds, right? And so once you have that time, or once you have the function, you plug it in there after taking the derivative, okay? Now, the average speed is going to be simply calculated by dividing the total distance traveled by the elapsed time. That doesn't change between a physics 1 versus a physics C method. But again, instantaneous speed, right? So if I say V instantaneous is going to be the absolute value of the instantaneous velocity, okay? Because it's the magnitude, and magnitude is represented by what looks like a double absolute value symbol. Okay, so again, just remember that average, right, equals a secant line. Instantaneous, sorry, I forgot the U, equals a tangent line. Okay, so now let's look at an example problem. So again, this is what sets it apart between algebra and calculus. Okay. So let's look at an example problem. So the position of a particular particle is given by x of t equals 3 meters per second t plus 0.5 meters per second cubed t cubed. Okay, so just a little bit of a preview. This means a non-uniform acceleration. Whereas in a physics 1 course, the acceleration would have been uniform. So what we're going to do is we're going to find the average velocity between 1 and 3 seconds, and then we're going to find the instantaneous velocity at 2 seconds, which is kind of the halfway point between these two intervals. So if I do just a quick sketch of what does this function look like, right? So it's a cubic function. So again, I'm just going to sketch this. So it's like 1 and 3. Here's 2. The scale doesn't make sense. So let's change that up a little bit. Let's get it to a scale that makes sense. Okay, so maybe this is 2, and then this is 3. So my function is going to do something like, that. But remember, this is a cubic function, so it's going to kind of tail off on that side. So I don't think this is a parabola. Okay. So what I need to do to find the average, I'm going to put, find this the slope. Sorry, my iPad's moving. The slope of the secant line between points 1 and 3. So what does that mean? I need to find x of 1, and I need to find, x of 3. And then I find the slope because here's my delta t, okay? But I need to find my delta x by finding those 2 points. So the first thing I'm going to do is find x of 3, which is going to be, I'll just kind of shorthand it here, right? So it's going to be 3t plus 0.5t cubed, and so it's going to be 3 times 1 plus 0.5 times 1 cubed, which is equal to 3.5 meters, okay? Oh, sorry, that's x of 1. And then x of 3 is going to be 3 times 3 plus 0.5 times 3 cubed. And that's going to give me 22.5 meters. So now I can find the average velocity. And again, average velocity is notated by V bar, right? The bar means average. So in physics C, you're going to get some of those more mathematical terms and symbols. So we're going to do, sorry about that. So we're going to do delta x over delta t. So we're going to do 22.5 minus 3.5 over 3 minus 1, which gives me an average velocity of 9.5 meters per second. Okay, but one thing to note is that 2 is halfway between them, right? So now what I'm going to do is, now I'm going to do my instantaneous. So I'm going to take my secant and turn it to a tangent by bringing my delta x down to 0 by simply taking the derivative. So v of t is going to be the derivative, right, of x of t. So it's saying d dt of 3t plus 0.5t cubed. And then it's like I'm going to kind of evaluate that at x equals 2. Okay. So the derivative, sorry, this is going to be v. Oh, no, that is the x. So v of t, the derivative is going to be 3 plus 1.5 t squared. Okay, because remember, when you do the power rule, this comes down here. So I'm going to multiply 3 times 0.5, and then I'm going to subtract 1 from that from my exponent. Remember, when you take a derivative, it takes out an order of magnitude of the exponent. So now I'm going to evaluate that at t equals 2 seconds. So v of 2 is equal to 3 plus 1.5 times 2 squared. So 2 squared is 4. 4 times 1.5 is 6. And tells me that at 2 seconds, the object is moving 9 meters per second. So this gives you an estimate, and it's pretty close. And if I were to take like 1.1 and 2.9, 1.5 and 2.5, right? So like as I shrink that down, that delta x between them, as I shrink it down, that 9.5 comes closer and closer to 9, which is my actual value at that point. So again, in this video is where we start our conversation when it comes to calculus. And we're going to keep building that in the next video when we, again, distinguish between average and instantaneous. But now we're not going to look at velocity. We're going to look at acceleration.